Hello everyone. In this video, I will try to answer a question about working out the order of a reaction using experimental data. Of course, we agreed before that we cannot determine the order of the reaction or the rate expression without having experimental data, without doing an experiment. No, we cannot do that from the equation itself, but we can do that using experiments. For that reason, here we have work out the order of a reaction of this reaction with respect to D. As we agreed before, to find out the effect that will happen to the rate when we are changing one of the reactants, we have to control a reactant. We cannot change both reactants, okay? We should have one reactant controlled and study the other reactant. For that reason, to find out the order of reaction with respect to D, we should have E controlled. How can we have E controlled? We will check, or we will choose, or we will use here experiments 1 and 2, where the concentration of E is controlled. Concentration of E is controlled, so what will happen to the rate is because of changing the concentration of D. What has happened to concentration of D? It has been multiplied by 4. It has been multiplied by 4. And if we checked what has happened, what's the change that happened to the rate from experiment 1 to experiment 2, it has been also multiplied by a factor of 4. So they have the same change. They have the same change. For that reason, we can say that rate is related to or proportional to D, first order. This is first order. This is first order. Why first order? Because changing the concentration of D by a factor of 4 will change the rate by also a factor of 4. So it is first order. The effect that will happen to the rate is the same effect that has happened to the concentration. Okay, what about the next point? For the next point, we have to work out the order of reaction with respect to E. With respect to E, we will do the same thing. We have to choose two experiments where E is changing and D is constant or fixed. But we do not have experiments. We do not have here experiments where D is fixed. So what we will do, it's a bit tricky, but it's not that difficult. We will introduce another experiment. We will introduce another experiment. We will predict another experiment. How can we predict that? It's not that difficult. Why? Because we already know that if we increase D by a factor of 4, R will increase by a factor of 4. So let's say that E is controlled. Let's say that E is controlled after 1 and 2. So E is 5.00 by 10 to the power negative 3. Okay, so E here is controlled. Let's say that we will multiply D by a factor of 4. From 2 to our new row, let's call it 2A. Let's call it this new experiment 2A. What will happen? It will be 4.00 multiplied by 10 to the power negative 2. We already know that multiplying the concentration of D by a factor of 4, multiplying by 4, will make the rate. Also, we have to multiply the rate by 4. So it will become 6.84 by 10 to the power negative 3. You will do it in your calculator and you'll have this number. If you multiplied 1.71 multiplied by 10 to the power negative 3 by 4, you will get this number, which is 6.84 multiplied by 10 to the power negative 3. One of you will ask, why did you multiply by a factor of 4? Why didn't multiply by a factor of 2 or any other number? Because by the end, we will have an interesting thing, which is 2A and experiment 2A and experiment 3, we have D controlled. As you can see, D is controlled, D is controlled, but E is changing. And now we can study how changing E will affect the rate. So it's easy now to find out the effect of the effect that will happen to the rate by changing the concentration of E. Okay, let's check what will happen. So D now is fixed. D now is fixed, so we don't have to think a lot about that. But for E, E has changed, okay, right? E has changed, okay, multiplied by a factor of a number. But the rate, oh, nothing happened to the rate. What does it mean when the concentration of a reactant is changing, decreased, increased, whatever will happen, it has been changed. The concentration has changed, but the rate is still the same. It means that it is zero order. It means that R is related to E to the power 0. It is zero order. For that reason, if we would like to give an answer for C, what's the rate equation for this reaction? R is equal to, we have to introduce our constant here. So K, it will equal, so R is equal to K multiplied by D, concentration of D, then it's to the power 1, and E to the power 0, so it is 1, so we don't have to include it, and here is our rate equation. If you included E to the power 0, it will not be wrong, so you can do that. Hope it's clear. See you later.